Unchecked data growth and data sprawl are having a profound impact on life sciences workflows. As data volumes continue to grow, researchers and IT leaders face increasingly difficult decisions about how to manage this data while keeping the storage budget in check. Stay tuned and learn how to overcome these challenges through next-generation architectures that deliver cloud scalability, rich metadata, and data durability. In this Infocast, we'll hear one of HGST's solution architects discuss the risks of RAID and data preservation and storage density, how Erasure code enhances data preservation, and best practices in data management and cloud models for deploying a scalable, state-of-the-art solution supporting life sciences workflows. And now, it is our pleasure to introduce Phil Sciutto, Director of Solutions Architecture at HGST.
So now it's a question of how do you make this happen? And how can, when we look at solutions in life sciences, first we'll start off with requirements. And I have to say, as a storage architect and someone who's been in technology for quite a while, life sciences doesn't make it easy. They set the bar fairly high. Typically we look for similarities and ways to really constrain the technology that we're required and sort of the requirements that drive some of those technology designs. And unfortunately, in a life sciences workflow, you're really all over the map. There's no set file or access pattern. Small files, big files, you need it all. You need it fast, you need high IOPS, you need high throughput. You need to be able to access that data from a number of clients, both within and without the organization. It's a workflow that really drives a high level of collaboration. Namespaces are important. You don't want to have to really go to multiple targets with each project you're working on. In many cases, having a single target to access all that data for longitudinal analysis is very important. Scalability, as projects pile up, as longitudinal data grows, as David and Ilkay mentioned, these data capturing is getting bigger. Data's doubling, and even individual data captures are growing at a tremendous scale. So the ability to rapidly adjust to the demands that new innovation and new technologies are driving to your storage requirements, continue to drive the ability from a provider's endpoint to be very flexible and change as the innovation drives those requirements. Do you need it? And you need it in a number of different, serving it up in a number of different ways. Do you need NFS? Sure. Most of your analytics compute clusters are running NFS. Unfortunately, the sequences are typically writing CIFS. Then you've got long distance requirements that will drive some kind of object store, either S3 or Swift type of a protocol. So once again, you need it all. And ultimately, you want to be future-proof. And oh, by the way, can we do this quick and can we do this for a low cost? So, it's really set a very high bar for us from a design standpoint to be able to deliver those kinds of solutions. Fortunately for us as a storage provider, we provide a full spectrum of storage, everything from the very high-end tier 0 types of devices, PCIe cards, high-speed flash, all the way down to the long-term archival requirements down at tier 3 with object storage. And so for us, it's really to help you to accommodate each one of those tiers, use it where it's appropriate, and be able to scale individually into each tier as needed. A good example of this, and it's something that I draw on from my own experience back when I was an IT director, is buying SAN back when it was mostly populated with spinning disk, and realizing that I needed way more storage than I actually needed for my use because I needed the spindles. The upside was I had all this capacity because I had this spindle-driven IOP requirement, had all this extra capacity, and so I could just put everything on my SAN. The downside was it was a little more expensive than I required. The advent of flash technology, it's a little more expensive, but as the diagram here in the lower right will show you, it can be a very cost-effective approach to utilizing different storage tiering. So just using relative pricing, the orange box, which represents object storage, and over on the left, we see a legacy system where we're using that fallow space on an existing spinning disk high-speed platform. 15% of its active data, 85% of its archival or fallow data. And that's typical for an unstructured data type of use case like we're seeing in life sciences. And if we look at object storage as being essentially half the price of that high-speed NAS storage, and then we look at flash as being about 4 times the cost, or twice as much as that high-speed NAS storage, if we're able to tear off that 15% of data, you're going to look at about a 27% cost reduction, and yet you're also going to get a 10 to 20% performance increase for that high-speed scratch storage that lives in that 15% of your active data. Cost reduction, and yet an increase in capability. It is possible to have it all. But it makes it it adds a little more complexity. It adds a management burden. But there's also some risks with staying on some of that traditional storage that I want to go over with you. And it's one of those ways in which, we sometimes have to reevaluate the ground on which we stand on. And we like to talk about, just point out that one of the reasons you don't see a lot of RAID-based solutions moving to more than, to very high density disks, usually not over 4 terabytes, is because of the RAID problem. So you get some of these traditional storage platforms that are still running RAID 5, RAID 6. And as you see, and I know the graph's a little small, but ultimately as we start to get into the 6 terabyte drives and above on the standard NAS type of bit error levels, we're seeing that at the RAID 5 level with 6 terabyte drives, these numbers that are highlighted in red for RAID 5 and RAID 6, those represent the possibility of an unrecoverable read error on a rebuild. You see at the 6 terabyte drive level with RAID 5, you have a 90% chance of not being able to recover a RAID array on a rebuild. Now, some of this is obfuscated by smart technology and some intelligence that's built into the drive, but those statistics really do point to the fact that RAID 5 at high density storage solutions is essentially dead, and RAID 6 isn't very far behind. If you go to the higher cost enterprise level drives, which are an order of magnitude greater in their storage or the disk reliability, we're still into very unacceptable numbers from a RAID array recovery level. Additionally, when you look at some of the other protection schemes that are out there, when we look at object storage, our platform, the Active Archive, uses erasure encoding. And in order to get to that high level of durability that allows you to eliminate backup as a requirement for maintaining that data, for preserving the data on disk, the problem you run into with replication schemes, which are an alternative that a lot of other competitive solutions have, is that they're typically going to run about 3 or 4 copies of that same data in order to maintain a high level of durability. As the green line indicates, in order to get to that level of durability, you're going to have a 3 to 500% disk overhead. For every gigabyte you store, you're going to use 3, 4, 5 gigabytes of raw storage in order to accommodate it. With erasure encoding, which is represented by the red line, we can get to an extraordinarily high level of data durability without a lot of disk overhead, typically around 60%. So you get to use more of what you buy for the data you need it for. Okay, so now we get to the tough part. Once we have these multiple tiers of storage, how do we treat it like we did back when we had it all on one single appliance? How do we get our cake and eat it too? How do we get that storage efficiency, that cost efficiency, and that performance increase? You start to look at management layers, storage abstraction, solution, that gives you that ability to look at your solution in an abstract way, to see it all as one big federated piece of storage. But behind the scenes, it's doing data movement, policy applications, in some cases heuristics, applying a universal namespace that lets you treat your data the same no matter where it is, and ultimately is transparent to your end users. And it also gives you a tremendous amount of flexibility to eliminate vendor lock-in. So, I'm sure all of you have had that uncomfortable 5th and 6th year support solution with your storage vendors and everybody else that you deal with, where once the hardware comes off a warranty, those support levels go up, or the support costs go up. And you're at a position where you've got a lot of critical data on a system, no ability to move it off, long timelines, a lot of disruption. This really does help level the playing field. Once you've abstracted that storage behind that abstraction layer, You can move it. These systems can move it, migrate it, and really automatically retire solutions as they fall off a warranty, as they become less cost effective, or as other innovations come into practice that maybe supplant those existing systems. So we've got, a couple of solutions that are very broadly used in the life sciences, iRods, and just from the folks down the street of General Atomics, Nirvana. Both of them are designed and have a strong participation from the life sciences environment, which I think, really does contribute to their applicability. And every vertical in every industry I talk to, there's always a unique aspect to everybody's solutions. And there's no one size fits all. These solutions really do take into account the way you use your storage, the way you access and manage your data, and they're constantly evolving. They're very active projects. And lastly, they give you a lot of control over that collaboration, the ability to create federated data spaces where multiple folks in multiple departments or multiple agencies can access the same data with different access controls. And then they also provide a consistent experience, which is hard to get with individual storage tiers. Anybody who's ever accessed an object store with hundreds of thousands or millions of objects knows that they're not very good at very rapid data or metadata retrieval. Anybody who's had to access millions of files in a file system knows that in some cases that's impossible. The nice thing about some of these layers is they really separate the metadata activity. They're very fast to search. They're very fast to index. And they really eliminate and provide a much more consistent experience from throughout every tier of storage. So yeah, there's a bit of a challenge to get it in place, but once it's there, the payoffs are tremendous. It's an example of where, federated data management, where you have one agency that's doing data collection, wants to share some of that information with groups within the same organization or even without, and extend it out to the cloud. And these solutions offer not just, an abstracted experience to on-prem storage, but it can, in many cases, folks will use it to extend that out to storage providers out in the public cloud like Google and Amazon. Oh, yay! I was like, wow, this is the secret slide. Obviously, I did this for the NSA. I like this slide. It always, it's always one of those cases where you talk to a group of people, they're all technical, and sometimes it's nice. And every now and again, I pull this up when I'm talking even to the staff internally, because I love how it really does help to drive home the various models of cloud deployment into something that I think we can all share, and that's pizza. I just saw on TV yesterday that they said pizza is the most addictive food known to man. And I'm living proof that that's absolutely true. So I think it's something we can all relate to. This is a really good analog for the various cloud deployment models that are out there. And really, we're looking at the left two. For most folks in the life sciences right now, they're either looking at doing it all in-house or outsourcing it to a provider like Amazon or Google and putting it all into an elastic cloud. The problem with that is that elastic services, the utility model that the cloud is pushing, is really just another word for renting somebody else's stuff. It's great for that elastic requirement, that utility model for compute, but for the data side of it, it's a persistent model. It's never going away. In many cases, you have to hold that data for months or years. Put a couple of petabytes up in the Amazon cloud or the Google cloud, and I promise you, they'll give you a gift basket. That's really what they're after. And so it's the same thing. It's like renting a car. It's like making a pizza at home every night. If you're doing it every night, going out to eat starts to get a little expensive. So the idea is that we want to look at that not only at that elastic utility of the cloud, but apply that same model to how we deploy. You can deploy all on private cloud, and there's lots of reasons for it. It may be that you have data locality issues. You have privacy issues. It's a little more expensive, but there's a lot of compelling reasons to keep everything on-prem. There's a lot of control issues. Likewise, if you've got a temporary requirement, including your data, put it all up in the public cloud. Spin it up quickly, do your work, shut it all down. But for a lot of folks, especially in the life sciences, where you've got a longitudinal data requirement, you've got to do that analysis, shut all that stuff off, but you've got to retain that data for months or years. An alternative may be a hybrid cloud model, where your compute, you can continue to flex up into the cloud as needed, shut it all down when you're done, but your data stays on-prem, where you can control costs and a consistent experience. And in many cases, the vast majority of your activity is going to happen on-prem as well, so you're reducing your data transmission requirements as well. So we reapply the pizza, stack to the real world. This is kind of what it looks like. The ability, it's not a binary decision anymore. Using some of the products that we have, and applying your requirements to that, you have the ability to have those gray areas on the server side, on the storage side, where maybe you're putting a lot of your persistent compute in-house. You're using the cloud to what we call cloud burst, and really extend that flexible, elastic model. Ultimately, it is a little more complex. There's a few more moving pieces, but the payoff is there. You're applying those architectures, you're getting that ability to scale and scale as needed in a very focused, granular way that you weren't able to before, which results in more flexibility, more agility, the ability to apply these solutions to your unique circumstance. And then, and the payoffs for some of this is the ability to really avoid some of the things you've been doing in the past. I'm sure everyone in here, if I ask for a show of hands, can tell me that they've backed up a petabyte of storage. Especially when you look at things like synthetic backup, it's not that hard anymore. But I'd love to see how many people have ever restored a petabyte of storage. I suspect, I've written a few DR plans, and there's a place where I like to say we go into fantasy land of this is, this I have to write, but I'm pretty sure at this point, I'm just going to attach my resume or my resignation and move on. So one of the things we like to say about it, with these levels of durability, we've got a zero TCO. I'm sorry, a zero RTO. Sorry. RPO. Yeah, and so, we don't have recover. We don't need to recover. We have no RPO, we have no RTO. It just becomes zero. It never goes away. It's always there. Especially for data like this, where you need high durability, you need high availability. These solutions give you that flexibility and give you the ability to really bring a lot of that fantasy land in your DR plan back to reality and something you can really support.
Thank you for attending our Infocast. From all of us at HGST, have a great day.